Hi, everyone, and welcome to Feed and Grain Chat. I'm your host, Elise Schaefer, editor of Feed and Grain. This edition of Feed and Grain Chat is brought to you by Watt Global Media and feedandgrain.com. Feedandgrain.com is your source for the latest news, product, and equipment information for the grain handling and feed manufacturing industries. Today, I'm joined on Zoom by Jax Williams, PhD, Business Development Manager for Trinamics North America. She's here today to discuss animal feed applications for handheld NIR devices. Hi, Jax. How are you?
I'm good. How are you?
I'm doing well. Thanks for coming on today.
No, thank you for having me as well.
Can you explain the science behind NIR analysis and some of the options that are available today?
Yeah, no, I think in order to understand how it works, we can kind of just take a step and understand what it is. So to give you an example, if you're going to learn anything from today, is the fact of if we think of our eyes, right? Our eyes sense the light and then we see an image. NIR is exactly the same. It's just instead of using your eyes in your brain, we put it into either a benchtop, an inline sensor, or something handheld. So NIR, near infrared technology, has been used probably since the 1800s and now all the way to today. But the fact is you have a sensor, so a piece of hardware that emits light, and that light goes to your material. Your material then can bounce back that information to your sensor, and that sensor with some type of other analytics called calibrations will then give you information. And so at the end of the day, you're getting information from light and matter to get something useful. And that's kind of what it boils down to, is what you see is getting quantified with a device. And so I hope that was, from my perspective, a little tidbit of kind of what I would say NIR is. But if we wanted to dive in a little bit more, as in, okay, we have a benchtop NIR, we have a handheld, we have an inline. What does that mean? I don't understand. Well, at the end of the day, it's going to come down to the application and your goals. What do you need? What do you need to measure? Do you need to measure the color of something? Is it red? Is it blue? Do you need to measure this grain of corn? What's in it? What is inside of this? How much starch is in there? And that's going to come down to the type of tool you need for your operation. And if you want to measure it fast, if you want to measure it slow, and also cost versus performance. Some of these instruments are $100,000 and some of them are $1,000. And so the $1,000 instrument is not going to outperform the $100,000 instrument. However, they can still serve a usage. And that's kind of the voice and the vision that I want to give today, is what the application you have to fit the tool to and the cost versus performance. So inline is fantastic, right? You don't have to touch it. You put it in your operation and it just scans automatically. However, that has a whole nother set of calibrations, there's a whole nother set of technology, and it's amazing. Lots of sensors, but also it has to be dust proof, it has to be temperature proof. You have to have a stainless steel casing so it doesn't corrode. So the hardware gets expensive. Same thing as if you want to buy a tractor. You can't just buy one, right? You got to have one fit to your actual field, your use, your temperature, your environment. Same thing with benchtop. They're amazing. They have a wide spectral range. They have multiple sensors. They can do great things. I mean, with my PhD, I've used them quite a lot, but they're also very costly. And so that might not fit the usage. Where handhelds are offering a new breadth of space where we can still get a lot of information, but it's not as costly, right? You're talking at the range of anywhere from $5,000 to $1,000.
For facilities that have decided that the handheld NIR is the tool for them, do you have any operations tips to ensure consistent results from user to user or from one device to another?
Yeah. For one, I would definitely know your tool. So every single tool is manufactured differently, as in it's not the same. When you think about how something is produced, just because it's an NIR doesn't mean it's the same NIR. As in, if you want to drive a car, it's different than driving a truck sometimes, right? They're different. They're built differently, but it's still a vehicle. So anyways, there's different types of sensors. There's different types of hardware and just different types of modeling. So there are a lot of moving parts here. But at the end of the day, the biggest device I can do is know your tool. as in how best do I measure with my tool that I have here. I'm sorry, if you want to unscrew a nail, right, you can't be using a hammer. In fact, sometimes I do because it works, but is that the best way? No, I'm going to destroy my material. Same thing with your handheld, as in if you have a handheld where your spectral window is very limited, right, you can only measure between, let's say, 700 nanometers to 1200 nanometers. I'm sorry, but if your window of vision, so what I mean by the spectral window is imagine we're looking through binoculars, right? You only see that little pinpoint over there, but you're not seeing the full spectral window, right? And that's what that wavelength means. If you have a handheld tool that says my spectral window is only 700 to 1200, you're only seeing this little portion of your material, which means when you're wanting to look at starch, and starch has a doublet around 2100 nanometers, you probably need to have a tool that needs to look at that full window. So if you know the sites, that spectral window of your instrument, the better information you can gain out of it, but the better you can fit to your tools. However, if you don't really need that, then that's fine. Yeah. Anyways, know your tool. If you have questions, reach out to me in a release. Hey, what question should I be asking? What is your spectral window? What's the temperature dependence? Is it robust? Can you take your device and drop it? Yes, like that matters, because if it's not built tough, it's not going to last and give you great data because something internally is broken. Some of the sensors and how they're built have moving parts, which means if you move the device and then scan it, you're not going to get an accurate representation of your sample. So know your tool is the biggest piece of advice I can give.
What role does calibration play in the operation of handheld NIR devices?
I think that's probably one of the best questions. And I always follow it up with, between you and me, right? I think we both would have a different definition of red. Would you agree?
I think everyone would, yeah.
Everyone would, right? And so calibrations are very similar. As in, if I make a calibration and if you make a calibration, you might tell me similar things. It's still red, but it's not really identical at the end of the day, unless it's, verified and XYZ. So calibrations really highly depend on the sample set that you want to, let's say, make a calibration from, which means it's always hard because when I first started in this industry, it was like, what's a calibration? Like, I don't understand what that is. So then you have to dive back. And all it is just, you're just calibrating back to a reference point. Okay. How do we know that it's light outside? Well, it's bright. So we have these different common things. How do you know it's summer? Well, it's warm in some regions. It's nice outside. You can smell it. You can hear the birds. Calibration are the same. As in, if you have a sample set that has a protein range between 9 and 15, and that whole sample set of 100 samples has that protein between 9 and 15, I can then make a calibration that predicts those levels of protein, right? Just like I know it's summer, just like how I know different colors we have those different prediction levels. So calibration is just like a fancy term to just say, how best can I predict what's in my sample? And how do I do that without having to destroy my sample, without using harsh chemicals, without using wet chemistry, right? It's a non-destructive method. And how do I analyze my sample set that I have, but then extract the best data reliably? Which means if my sample set has, let's say, a piece of protein that's way too high and it's never containing, let's say if it was 9 to 12, and I have something new coming on and it's sitting at 20, right? I will say the calibration will most likely not predict that 20 because that calibration has never seen that 20 data point before. And it's very true as us as well. It's no different that if we've never seen summer before, we're never going to be able to know what summer is without predetermining it in the definition. Now it's really easy to add it to the calibration or create a new one, which is why we have, all of these different models and all of these different where feed apparatus, it feeds and, hey, we want to extract amino acids, we want to extract starch, we want to do this. We're constantly making sure we're inputting that into the calibration and updating it because it matters, right? We have new seeds that come all the time and new genetics, and they produce different types of starch levels or different type of protein levels, and that matters, and we can definitely measure it. We just have the need to constantly update our calibrations, which is perfect, because then it's not like we're taking data from 200 years ago and still using it today. We're just developing it over time.
Wonderful. Now, are there any special considerations that feed manufacturers interested in this technology need to have on their radar?
Yeah, I think at the end of the day, it's just understanding your process, right? But understand that these tools are here to help you. They're not here to fight you, right? They're here to say, hey, we understand that there's a need in this industry, not just this industry. Like, I've played in a lot. It's the fact that we want to lower costs as much as we can, and we also want to give value back. Where if you don't have to sit there and second guess if even your own equipment is operating, like if you had something internally that you can just use to check to make sure that your operation itself is optimal, that could save cost over time. So it's understanding that these tools aren't just for the short game, they could also be used for the long game. So if you zoom in and you zoom out, say you track over time that this one instrument, you're tracking moisture, and you see that your moisture starts to go up, and it's like 6 months later, you're like, oh no, I have to replace a part. But if you did that type of work, you had that type of data in the background, you can have a red flag in your system that says, hey, by the way, this is a little out of spec. And then you might be able to order a part and then save a whole, line from going down. But on the same note, you can measure what's coming in. Like my grad school professor, and he was like, if you put junk in, you're going to get junk out. And he was not wrong. As in, when you measure the quality of your grain, or if you measure the quality of your incoming raw materials, it could really help the operation in general with a smooth all the way through. But if you don't know what's coming in, the quality, that's what these handhelds can offer you. But it's not just quality coming in, you can also measure what's coming out, right? It's just having extra eyes. I'm not saying you need to go sample everything all the time. Find out what works best for you. Find the people around you who do it well, and hopefully integrate these tools the same way they do, or be creative. As in, for this month, we're going to measure our material. We're going to see what happens. Oh, wow. I really was not aware that when I did switch suppliers, that this one raw material was not exactly what I was receiving. So be a scientist, be creative. Call me up if you have questions. I'm like, sure, let's try to put it here. Because at the end of the day, it's your process. And you got to do what works best for you. And that's what I want to do here in Elise Sears. We want to give you the best tools for the job, as in allow you to have higher performance, lower cost, and greater optimization at the end of the day. And that's really what we're here for.
Well, Jax, thank you so much for your insights today.
Yeah, you're welcome.
Well, that's all for today's Feed and Grain Chat. If you'd like to see more videos like this, subscribe to our YouTube channel, sign up for the Industry Watch daily e-newsletter, or go to feedandgrain.com and search for videos. Thank you again for joining us, and we hope to see you next time.